All right, so here we go. Let's get started, and we'll rock and roll. All right, so Coach Jay decided, here's the scenario, that he was going to, over the month of March, take random days throughout the month of March and calculate the total number of hours that he slept. So, over that course of time, he recognized that that was a bad day right there, right there. How many of you are right here? 3 today.
Oh, I had one today.
From last night. So let's pretend that I took the information, and what you see in blue here, all right up here, make sure, what you see up here represents the days that I randomly selected, okay? Now, as we look at this, we recognize that the number of hours of sleep are mu of x, which would be our mean, our standard deviation, which is 1.51, and our, what was this, sigma squared? Variance, good Julie. That would be the variance that would be there, would be 2.27, okay? Now what we're going to do is we're going to modify this just a little bit. And before I get to all these rules and stuff, the big thing to note is these are not on the formula sheet, okay? And then also, we must apply them in context, okay? That's kind of the key for this. It's not extremely hard, but you must note not only what the rules are, but how I would apply it in a context. So that's the big thing to kind of note. Now, just like with what Julie said, when we go to variance, right, when we go to standard deviation to variance, we're going to square it. But let's say we took this and we had a variable y. And instead of finding now Coach Jay's hours of sleep, we're going to find the number of minutes of sleep, okay? So in doing that, can anybody kind of help me out with what would happen to my mean? It's going to increase, and we're going to multiply it by 60. Good, okay? So just as a heads up, when we multiply every value by 60, the mean too will multiply by 60. So 60 times 6.4 gets me 384 right there, okay? Now let's go to the standard deviation. If I were to do 60 multiplied by all the values, would that impact my standard deviation?
Yes.
Yes, it would. Good, Jordan. So it'd be 60 times 1.51. Okay? Again, it impacts standard deviation as well as mean. Okay? So once I do that here, 60 times 1.51, we get 90.6. Okay? All right, so what do I do to go from standard deviation to variance again? We square it. Good. So we're going to do 90.6 squared. And when I do that, I get 8,172. Okay? All right, so does multiplication have an effect on everything?
Yes.
Yes, it does. Good. Now we're going to change it around just a little bit. And now we're going to go to adding and subtracting. We're going to see what happens if Coach Jay decides that during his AP stats class that he's going to take a 20-minute nap every day. Okay? All right, I thought about it, but I didn't go through it. But that would be cool. But not now. We can't do it now. All right. Now, what if I took a 20-minute nap on top of 384? Would that change my mean?
Yes.
It would. 384 plus 20, we would add to get 404. Okay? Because it doesn't impact mean. Now, what if I added 20? Would it impact my standard deviation?
Yes, but you can't add it. Well, you can't add them, but it's going to impact it eventually.
If I took, all right, everyone, hands here, hands here,
You can't add, it's going to change, isn't it?
hands here. If I add all the values, what happens? It moves. Does the center change? Yes. Does my standard deviation change? No. So this would be 90.6 right there. Okay? Would my variance change? No, it'd be the same thing as what's on top as well. Okay? Because of, remember, that's a huge thing. Standard deviation does not change. Okay? Now, again, the rules from this is more like applying it. If we multiply and divide by A, that will mean what? What would we do with our mean? Multiply and divide by A. Good. If I added subtract B, what would happen to my mean? Good. It would just add and subtract. Oh, there we go. iTunes. Let's go. Add and subtract by B. Okay? All right. Is everyone with me? All right. Now let's talk about standard deviation. What happens? If I multiply and divide by a, go right ahead. Y'all are taking breaks today, aren't we? We going? That's what I see. I see that. As we multiply and divide by a, we want to make sure that that impacts also the standard deviation. So whatever I do here, also with multiplication, we'll multiply and divide by what?
A.
Good, by a. All right. What about the adding and subtracting with standard deviation? Good. It stays the same. I know this is boring. I just want to make sure we get it. Okay. Variance. What would we do with standard deviation to variance?
By A.
Close. Okay. Look up here. 2.27. We multiplied by 60 to get here. Do you see how that's not true? But what did we do to standard deviation? We had to square it, right? So it's not just a, it's a squared. Because to go from standard deviation to variance, you must square it. So we would say in this instance that we would take the variance, multiply and divide by a squared. Okay? Let's do this. Let's put max down because I want to make sure you're all in. Okay? Awesome. Variance, would it change with adding and subtracting? No, that it would be the same. Rock. Okay? So that would be kind of the top part in terms of the first rule when we have multiplying by a value or adding by a value. Okay? Questions up here? Okay, down below, I think this will make sense here. We're going to take two variables and add them together. So let's say we have two samples, we have a mean, and we have a standard deviation. Let's just talk through that, okay? X plus y, what about the mean? What would we do with means if we added x plus y? Could we add the two means together? Yes, we could. So we would say 6.4 plus 6.2 equals?
12.6.
12.6, good. Okay? Could we subtract them?
Yep.
Yes, we could. So we've got 6.4 minus 6.2 equals? 0.2. Nice. All right, what about the standard deviation? Well,
No, you have to do something.
Variance
Oh, I'm
plus
sorry.
variance of the other.
Oh, come on.
yeah, what do we do with that?
Square both standard deviations and add them and then square root.
Square root, standard deviation.
Bingo. One cannot simply add standard deviations. There's our gang sign. I got you. Flash that gang sign. 1.51. I want someone to do that before they graduate.
I'm gonna do that
Walk
one.
across the stage.
I'm gonna be like,
Right here.
That'd be so
Get Tony to do it. Get Tony.
Is that bad? Did I just do something bad?
Wow, Sarah, official?
All right, plus 1.98 squared, and then we're taking the square root of it. Okay. All right, rock and roll. So once we do this here, once we take the variance, which is the squared, add them together, take the square root, you get 2.49 here. Okay. What happens if you subtract 2? Does that change the standard deviation formula?
Wait.
You threw me off. You threw me off. This would be the same.
It is not changing.
Okay? It does not change. If you add or subtract them, it doesn't change it.
Wait, what's the formula
Yeah, I'll do my
for
next
adding standard deviation?
It's the square root of the first standard deviation squared plus the second standard deviation squared. Okay? Are we good?
What
Alright.
is the second one? You subtract?
It's actually the same exact thing. Whether you add or subtract with standard deviations, it remains the same. So it's still 2.49 here. Okay?
Okay.
And then again, just so we're aware of this, this right here, if I squared this up here, I want to analyze up here just so we're here because this is the big part. When I square this right here, what goes away? The square root, right? Very good. Very good. You could also square this as well, okay? Some of the things you see as a teacher, only I can see them, and so that's why I start laughing. So you could literally do 1.51 squared plus 1.98 squared. When I do that there, that's where I get 6.20.
Square first.
Cool? Say again?
You have to square first and then add order of operations.
Yes. Did I?
No, I'm
Change
just
that?
like, no, I'm just joking.
Oh, you were
You're
just
saying
messing-
like, what does a square root do?
Oh, gotcha. Gotcha.
Okay.
Yes. PEMDAS is key. Okay?
That's how you get a five
All right.
Nike stats.
Right here, as we keep going, this second one on the right side would stay the same, right? This would be 6.20, and that would be the end on that.
So
Okay?
you're just squaring the standard deviations at the bottom?
Correct. You're just squaring it. I'm looking on this too, Jordan, just so you know. if I squared the formula before I got 2.49, I could square this to get here, right?
Okay.
But if I squared this up here, do you see how the standard or the square root goes away?
Mhm.
Same thing over here. Just so you know that, just kind of have an idea on this. Okay.
Welcome back.
Okay. Hey, over on this side, I just want you to see this. Okay. All right. Let's make sure. Talking needs to go down so we can all hear. Okay. This over on this side, when we have the standard deviation, we square it, right? And then we add it to the other standard deviation square. Notice that's how we get these two formulas. Okay. Now, question: what are these two formulas? Where did these come into play?
The bottom one.
These.
The bottom one
Johnny,
is
I
for
heard you
proportions.
first before, and then I can kind of.
Well, sample is T portions for 2 portions.
Yeah, so this is the standard deviation for 2 sample, either mean or 2 sample proportion, right? It could be an interval or a sig test, but this is the standard deviation. I just want you to know this. That's where this comes from, because you can't just add them together. You can't simply add them. That's where it comes from this spot, okay? That's just kind of keep in the back of your mind, all right? Any questions on this slide? Because the next one is a lot easier than this one. A lot of rules on this one here. Cool. All right, let's go to the next one here, and we'll go from this point. This is the normal distribution, okay? On this one, we have the mean of 15,000 and the standard deviation of 4,000, okay? Now, as we look at this, there are 2 ways we can attack it, with the z-score.
Or with your normal CDF.
Nicely done. Good, Jordan. This over here, the z-score, be familiar with, okay? I will tell you, be familiar with. Multiple choice have taken a lot of problems from this, where you have to kind of know the formula. But if I was to do an FRQ, I would go to normal CDF here, okay? So question, if I said find the probability that a randomly selected day has more than 20,000 views, what would be my line? What would I highlight?
20,000 and then to the right.
Good, Jordan. So 20,000 and anything to the right of that side, okay? That's what we're trying to find. So to find that area, question, before I do that, what is the probability of the whole area under normal distribution? 1. Good. So we're trying to find a part of that whole. To do that, we got to find this area, and we can do that by doing normal CDF, right? Okay, good. So we got normal CDF, and then what would be my first value?
Your lower bound, upper bound.
Good. Yeah, so we'd have my lower, comma my upper, comma my mean, comma my standard deviation. Good. Okay, so when you see this here, you're going to see something a little different than maybe what we've shown before, but this is appropriate. By putting the lower, upper, mu, and standard deviation on top of what I've already put, you can actually do that to establish what it each means, okay? You don't have to, but you can. So this would be 20,000 to what's a high number?
996666.
No. No. We are GAC.
Good kill.
We don't say 666.
As you just
Just
said.
said it. You can say another one.
555.
What if you 666?
And so once I plug this in, I will get an area.
We're all good.
It's 2 sets of 3, so therefore 2 negative.
This will be a great podcast,
Think
by
about
the
it
way.
that way.
Wait, are we podcasting?
Yes.
Think about it.
Over here, this is 0.1045.
4,000.
46. What? 46. That doesn't look like it.
Yeah.
0.1056. Okay. All right. Couple things with this that I just want to make sure of. With the z-score formula, note. Okay. All right. Let's keep it down. I want to make sure we get through this. When we attack it using the z-score formula, it always finds the area to the left. So I could do this by finding the area to the left side. Just note that it's really the area that's to the right that we're trying to find, right? But the z-score only finds what is to the left of it. So that's important when you go, especially on a multiple choice, if they refer to it, be very careful on that, okay? Everyone good with the first one?
Perfect.
All right, the next one is this. They say find the area of the bottom 5%. What can I use in the calculator to attack that one?
Inverse norm.
Inverse norm. Very good. Good. Inverse norm would be area, comma mean, comma standard deviation. Man, was someone else who left it? Oh, Jackie did.
You're
Yeah.
hearing things.
When we plug it in for the area, the big thing to note is that it's anything to the left of that value. So when we look at the bottom 5%, my area underneath the curve that's highlighted is 0.05. Okay? Now what's my mean here?
15,000.
15,000, good.
Your standard deviation is 4,000.
Good, standard deviation is 4,000. So once I plug that in, I get 8,420. So that would be kind of that's my X value that's associated to anything that has the bottom 5%, okay? Again, be careful, it's anything with that value or less than that value, okay? All right, am I losing y'all today?
I'm here.
Yeah? Is it just because it's a Friday?
I have
Wait, I'm
not
really
exam.
Oh, okay, gotcha.
Wait, when do you use inverse
The
norm?
last Friday.
Anytime that I give you the area and I say find the value, that would be going backwards from what I did up on top there, Julie. Does that make sense? Okay. All right. Hey, right now I feel like we're really distracted today. You know, I want to make sure this stuff is very important because I want to make sure we can go through and review it. But right now I feel like we're out there.
Sorry.
You know?
We need to stand up and stretch and then.
Yeah, can we
Let's
take
do
like
it.
a 30
Let's do
second
it.
break here?
Please.
Alright,
Gotta go.
What? What's that? What was that?
What? I said, can we take a 30-second break?
I'll give you literally 20 seconds and I'm gonna begin again. Okay?
It was repetitive. You said people. That was funny. I just was saying that on you, but then you reacted scared. I was just like, I gave you one little tap and kept going. So I was like, I don't like it.
All right, grab a seat. Let's go. All right. Here's the deal. Here's the thing. Okay, you gotta own it. All right. I'm telling you, this is a coaching me again. You've got to own it. If you do not put in the time or effort or the work into this, that's on you. Got me? I'm trying to make sure that we go through everything here. So really dial in. All right. We got this last slide. Should not be long at all. Okay. Should not be long at all. But really dial in. Make sure if you have questions, ask me. Okay. Ask me there. All right. Remember this picture, right? We have the population. We have our voluntary and convenient sample. We also have this
SRS.
SRS, which is represented as
Simple random sample.
Population.
It's a
population. Good, Jordan and Johnny. So as we look at this, it's representative of the population. We use the simple random sample to estimate the parameters, right, or by population. Now, remember, a statistic is a measurement of my sample. A parameter is a measurement of my population, right? Now, the big thing to remember that I'm seeing on these AP rubrics is the notation is very, very important. If you don't write the right notation, they'll count off for that, maybe even not even giving you credit on that, okay? So if you're talking about proportion, make sure you're talking in terms of a statistic, p hat. If it's a parameter, talk about p, right? And then so on and so forth. I've also noticed that you can either use the notation or you can use the word. Either one of those two is actually fine by the AP exam graders. So if you're like worried about that, you could also do the wording as well, okay? But again, this is statistic. These would be the parameter notations that are there, okay? All right, so the only thing that we're really gonna talk through that's left is this idea of, remember the Beyonce activity? Remember that? Okay. It's like my favorite one. So when we looked at this, if you remember, we had two different samples that we took, right? We had our 5-word simple random sample. Now question, before I get to that, what is the difference between a sample distribution and a sampling distribution? Yes.
Sample distribution is like within like one sample, right? And sampling is within all the samples that you use.
You rock that. Nicely done. One sample distribution is taking it from one sample. Each dot represents one piece of data. But what Jesse said was, if I did a sampling distribution, I'm taking an average of a specific amount, averaging it together to get one of these dots, okay? So question, You may not be able to see the number, but that's okay. What does that dot represent for a 5-word sampling distribution?
The average word length for
Of
the
what?
last 5 words.
Good. This is 5 words averaged together to create this dot, right? What about one if I had 10 over here? Nice. The average of 10 words, get that number, that dot represents the average of 10 words, right? And so on and so forth. That's a sampling distribution, okay? They will not give you credit if you miss those or if you switch those up. So be careful. If you're talking sampling distribution, sampling would be if I average like a sample together and then use that average to represent one dot. It's like a sample and a sample. Whereas a sample distribution is if each dot represents one piece of data.
And so for that, it'd just be one word. It'd be the length of one word.
Correct. One word would be, that'd be exactly right. Good. Good, Jordan. Does that make sense? All right, so when we talk about the Beyonce activity, we remember that what happened when we went from 5 words to 10 words? Ooh, it kind of did, yeah. And then,
Variability
Variability.
increases.
good, what happens when I increase variability? Or increase sample size?
Your variability increases.
Good, variability decreases. So again, remember, if I increase that sample size, it's going to come tighter together. The standard deviation is going to be smaller, okay? So just note that there. Now question, 2 things need to happen to make a good statistic that estimates my parameter. Good, Johnny. Low bias, low variability. Someone explain to me, what's bias? What's bias?
Distorting the little, the numbers basically.
Yeah, it distorts the numbers a little bit. So if it distorted this number, if this 3.43 was my actual average, right?
Yep.
What would be something that, first of all, is this high bias or low bias here? If this is my actual low bias, why?
It's very close to the
actual.
It's close to my actual, right? So my parameter and my statistic are in alignment. That means that that's low bias, okay? Now, low variability just means that they're tighter together, right? Tighter together there. How do I decrease bias? Tell me.
You increase the number of samples.
If I increase the number of samples, that decreases variability, right?
Yeah.
Does that decrease bias all the time?
No.
Yeah, so what decreases bias, Andrew?
It's like the sample sizes for each of those samples.
Well, I could increase the sample sizes of each of those. That's true. We're still kind of around it. We know, Maria?
Is it making sure that everything's random?
Bingo. Randomness, right? If I look and see if something is random, in that instance, that would decrease my bias that's there, okay? Now, we kind of hit all over these. But does that make sense a little bit of what we were talking about? We kind of hit and went all over there and went from there. But it's good to go. Good to go. Questions on this? Okay, here's what I want to do. Great focus on that last one. When we go to our next segment, I want you to do the first 7 questions, okay? And we'll do this. We have 15 minutes. So I'm going to give you 10 minutes to do this among the group here. And then